3.4, section 3.4, complex numbers. First off, let's review imaginary numbers. I is just the square root of -1. So therefore, I squared would cancel the square roots, just -1. I to the third would be -I, -1 times I. And I to the fourth would just be 1, because it's 2 squared, so -1 times -1 is +1. And this is a cyclical pattern, so then I to the fifth would just be the same as I. I to the sixth would be I squared. I to the seventh would be -I. And I to the eighth is the same as I to the fourth, just 1. So the shortcut would just be divide by 4, and your remainder tells you what it's equal to. The remainder is 1, 2, 3, or 4. A complex number is mixing a real number with an imaginary number. So they look like a plus bi, where a is the real part, b is the imaginary part. So let's go through a couple examples. 3 plus 4i, that's a complex number. 3 is the real part, 4 is the imaginary part. 1/2 minus 2/3 I. 1/2 is the real part. -2/3 is the imaginary part. 6i. So this is the same as 0 plus 6i. So the real part is 0, imaginary part 6. For -7, there's no imaginary part. You could say 0i. So the real part's -7, the imaginary part 0. Just like any other numbers, you can add, subtract, and multiply complex numbers. And when you do so, it's just like when you do a binomial. You just treat I like x, like a variable. So for if you are adding, you combine like terms. You'd add the real parts together to get a real answer. You add the imaginary parts together to get an imaginary answer. For subtracting, you would just distribute the negative and combine like terms. And then multiplying, you have to FOIL. With that, you'll get an I squared, so you need to remember I squared equals -1. So let's add. We add the real parts. 3 plus 4, you get 7. Then we'll add the imaginary parts. 5 and -2 is 3i. For subtracting, let's distribute the negative. So you change the signs. Then add the real parts. 3 and -4 is -1. 5i plus 2i, that'll be 7i. For multiplying, we said it's like FOIL. So 3 times 4, you get 12. 3 times -2i is -6i. 5i times 4, 20i. And last, 5i times -2i is -10. I times I is I squared. Now, my little shortcut, anytime I see an I squared, I cross it out and change the sign, because I squared is -1. So now we have 10 plus 12, which is 22. Combine the real parts and combine the imaginary parts. 20i and -6i is 14i. For this last one, we have I to the 23rd. So I said before, all that matters is the remainder. So if we divide 23, divide by 4, 4 doesn't go into 23, but it does go into 20, so that's 5. 5 times 4 is 20. Subtract, we get 3. So 3 is our remainder, which means this is the same as I to the third, which you should know is negative I. When you're dividing complex numbers, it's really the same as dividing radicals. You have to rationalize the denominator. And the process is pretty much the same too. You multiply by the conjugate, and the conjugate's just the same numbers with different sign in between. So we're going to multiply by the conjugate of the denominator. So 1 minus 2i would change to be 1 plus 2i. And you have to do it to both top and bottom, which means it's really two foiling problems. So 3 times 1 is 3. 3 times 2i is 6i. 5i times 1 is 5i. 5i times 2i is 10i squared. Over 1 times 1 is 1. 1 times 2i is 2i. Negative 2i times 1 is negative 2i. And negative times positive is negative 4i squared. So the same thing as before, I squared, I crossed it out and changed the sign. So then we combine like terms. 3 minus 10 is negative 7. 6i and 5i is 11i. Two I minus 2i cancels out, and that should always be the case with conjugates. So we're just left with 1 plus 0, no, 1 plus 4. We have a 4 over here. So that's over 5. So there's the answer. You can split this up to be more of a plus bi form, which would just be negative 7 over 5 plus 11 over 5i. For example B here, this is 0 plus 4i, so its conjugate would be 0 minus 4i, which is just minus 4i. So on top, we need to distribute, so we get negative 28i minus 12i squared over 4 times 4 is 16. Since it's negative, it would be negative 16. I times I is I squared. And anytime there's an I squared, cross it out, change the sign. Cross it out, change the sign. So we get 12 minus 28i over 16. And we want to reduce both parts as much as possible. 12 over 16 is 3/4. Negative 28 over 16 will reduce to, divide by 2, we get 14 over 8. Divide by 2 again, 7 over 4. I. So now let's do an example where we have to use the quadratic formula to solve. So remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac over 2a. In this case, a is 4, b is negative 24, and c is 37. So we're going to plug all of that in. So negative b will be a positive 24 plus or minus the square root b squared, so we're doing 24 squared, 576 minus 4 times 37, which is 592, so minus 592, over 2a. 2 times 4 is 8. 576 minus 592 is negative 16. And square root of negative 16 would just be I times the square root of 16. And the square root of 16 is 4, so that's 4I. So this is 24 plus or minus 4I over 8. And now, just like we did in the last example, we're going to split it up and reduce. 24 divided by 8 is 3, plus or minus 4 over 8 is 1/2.